All right, class, welcome to chapter 1. We are going to start our college algebra topics with functions and function notation. So we will discuss all semester pretty much the idea of functions. And in this first chapter, we're going to talk about functions in general. And then we will concentrate specifically, starting with chapter 2, on linear functions, absolute value functions, quadratic functions, and so on and so on. Again, starting with the easiest kind, which are the linear, and then discussing more and more complicated functions. So, what is a function? Well, before we get to functions, I want to talk about what a relation is. So, relation is simply a set of ordered pairs, x comma y. In other words, it's simply a rule that connects two quantities. Relations can be given in different forms. So it doesn't necessarily have to be mathematical. It could be anything that relates to quantities. For example, days of the week, which we know what they are. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? To, let's say, number of hours of class time. And again, maybe you only have one class, maybe you are a full-time student, it doesn't matter, but let's say on Mondays, you're in class for 3 hours. And on Tuesday, you were in class for an hour and a half. And maybe, let's say, you have a big day on Friday of 5 hours, and then no hours on Saturday, Sunday. Okay, so then this would be our relation. Let's say Monday and Wednesday, you're in class for 3 hours. Let's say Tuesday and Thursday, you're in class for an hour and a half. Say Friday's a big day. And then Saturday and Sunday, you're in class for 0 hours. So we're simply connecting the dots, right? We're showing the relation of how the days of the week are related to the number of hours of class time. Okay. Now, of course, in our class, we're going to get more mathematical. So as I said, a relation is simply a set of ordered pairs. By the way, the set of ordered pairs I have created here, even with my diagram, would be Monday is paired up with 3 hours, right? Tuesday is paired up with an hour and a half, and so on and so on. So we did show this relationship with a diagram, but these relations can definitely be made up into ordered pairs as well. So here, let me give you a set of ordered pairs. So in other words, again, let's say if x is 2, y is 3. So remember, x comma y is an ordered pair. Therefore, we always know x goes first and y goes second. Here, let's say 1 is paired up with 5. 2 is paired up with 7. And let's say 6 is paired up with -1. Okay, so this is a set of ordered pairs. They might not tell you anything, but it's just as raw as the definition says. In other words, if x is 2, y is 3. If x is 1, y is 5, and so on. Now, of course, the kind of relations that we will be talking about mostly is coming from equations in two variables. So I can give you an equation as simple as x plus y equals to 5. This equation here describes a relation between x and y. So here are two numbers, x and y, and what we know is they always add up to 5. Now, this equation alone will definitely describe actually infinitely many ordered pairs. So if I think of numbers that add up to 5, you can think of a few yourselves and write them down. But again, remember, what we want to do is write those solutions as ordered pairs. So 2 and 3, by the way, 3, 2, even though they're the two numbers, same two numbers as 2 and 3, this would be a different solution because it very much matters who the x is and who the y is. So in this case, x is 3, y is 2. But of course, it's not just whole numbers that would answer to this. You can think of integers. You can think of decimal numbers, and so on and so on, okay? So we definitely can create infinitely many ordered pairs that satisfy this equation. Here, I'll give you another one. We are going to talk about these kind of equations later on towards the end of the semester. I believe it's chapter 8 when we'll discuss quadratic equations in two variables. And by the way, this equation right here that I wrote down actually describes a circle of radius 1, as we will see. So here, let's think of some solutions. So if I make x to be 0, I'm going to get 0 plus y squared equals to 1. So basically, y squared equals to 1. So what number times itself equals to 1? In fact, there are two solutions for this equation. Both if you square 1 and if you square negative 1, you're going to get a positive 1. And here the same way, if we make y to be 0, I have two choices for x. By the way, it's a dead giveaway. If you have an x squared, that means two solutions for x given any y. Same thing here. Y is being squared, so two solutions for y given any x. Okay. An equation and relation can also be given by simply a graph. So here, I'm actually going to graph these two equations that I have given you. Here I'm going to actually plot some of these points. I have 0, 5. I have 2, 3. I have 3, 2. And so on and so on. I have 1.5 and 3.5. So we've learned or we reviewed in the last section how to plot points. And by the way, that's a whole line of answers. If I plot these 4 points that we found for this equation, 0, 1, 1, 0, 0, negative 1, and negative 1, 0. And by the way, there are a whole bunch more answers. The point is they're all going to fit around this, what we call unit circle. So a circle of radius 1. All right. So all of these are relations. Again, some kind of relation, some kind of equation, somehow how we can connect two quantities x and y. Of course, most of the time we will connect them with an equation. That's going to be our job. But that's what a relation is. It puts an x and a y somehow together. Great. Now, a function is simply a specific type of an equation. Just the same as, let's say, an SUV is a specific type of a car, right? So we're talking about cars in general. Now, if I'm talking about SUVs, that's a car too, but it's a specific kind of a car. So same thing, a function is a specific type of a relation such that, so a function is a relation in which every possible input value, which is our x, leads to exactly one output value, which is a y. So we say the output is a function of the input. And we'll talk about this also in the next section. All the input values, all the x's make up the domain, and all the output values make up the range. So in other words, a function is a relation such that, so again, it's a connection between x and y's, such that, very important, for every x, there is only one possible y. Okay. So I want to take another look at these relations we had and talk about which ones are functions and which ones are not function. So in this diagram, days of the week. So again, for every x, there's a one y. So in other words, for every input, so if I tell you the day of the week, there's only one choice for how many hours of class time you have. So if I say today is Tuesday, how many hours of class time you have, this Tuesday connects to one y value choice only. It doesn't matter that Thursday also connects there. What's really important in a function, that if we give you an x, there's only one possible answer. So in other words, if I say today is Monday, how many class hours do you have? It should be 3 and 3 only, not like, 3 or 5 or 7, depends, right? So it should be, again, it's sure sometimes depends. Today I happen to film on a Monday, Labor Day, we have 0 class hours, but according to this diagram I made, there's only one choice for this day. So this is definitely a function. Okay. Let's look at this set of order pairs. So for every one x, there is only one possible y value. So here it is actually. X is 2, and this same 2 gets paired up with 2 different y's that cannot be possible in a function. So this is not a function. So in other words, if I say x is 2, there should be only one choice of y for that, not 2 different choices. Okay. So for every x, there is only one possible y. So you can't have the same x with 2 different y's. Okay. Now, if you look at this equation here, x plus y equals to 5, whatever I choose for x, there's only one answer for y. And you also can tell that because of that exponent of 1 on the y. So this is definitely a function. However, the x squared plus y squared is not a function, because I'm giving you an x of 0 and we're coming up with 2 different answers for y. Okay. So to determine, again, I copied this out of your textbook, whether a relationship is a function, look at the input and the output values. And again, you can't have for the same input 2 different output values. So which one of these are functions? So if I look, all input values are different, and so therefore they all have different y's, that's a function. All input values are different, so I don't have the same x. We're coming up with different y's. However, this right here is not a function because I have the same x that are paired up with different y's. And as I said, it's a dead giveaway when you look at equations, if the power of y comes with a 1, or the power of y is a 1, that means you get one answer for y for every one x. So these are functions. And right here as well. The power of y comes with a 1, so it's what we would call a linear equation. Okay, we're going to talk about those specifically in the next chapter. And we'll also talk about quadratic equations, so the power of 2. That means you get 2 answers for that y. So we can tell just by looking at what type of equation we are given whether it's a function or not. Okay, so y has to come with the power of 1. Now, I graphed these two relations for you simply by plotting all the ordered pairs that make up the equation. Of course, not all. There are infinitely many ordered pairs here. There are infinitely many ordered pairs here. I just plotted a few, and I happen to know how to connect them. In other words, the first equation solutions, I connected them with a line because I knew it was going to give me a line. The second one I knew was going to give me a circle, so I connected it with such. And how do I know? Obviously, a lot of math practice. And how will you know? The same way. So we will specifically look at all the linear equations in chapter 3, so you'll be able to identify them and know just by looking at the equation, oh, that's going to give me a line. And as I said, we'll be looking at the last one, the x squared plus y squared equals 1 type in chapter 8. So just by looking at equation, you'll be able to tell, that's going to give me a circle. Okay. The point is, when we plot these points on the xy plane, and here let me give you another equation, for example. And that's one that we looked at in the R3, I believe. So when you look at a bunch of possible ordered pairs, so we plugged in a 0 for x, 2 times 0, 0 plus 3 is 3. Plugged in a 1 for x, 2 times 1 is 2 plus 3 is 5. So here I'm coming up, I'm choosing some x's, and I'm solving for the y's. Again, we practiced this in the last section. And here, let me pick another one, -1, for example, for x. And so -2 plus 3 gives us 1. So if I plot these points, 0, 3, 1, 5, -1, 1. You see here is the line, right? Okay. And we already know it's a line. The linear equation in one variable. Both x's and y's are to the power of 1. So that's what the graph of a function is. We just start plotting all the possible x comma y's. Now, even though I said there's going to be infinitely many of them, hopefully with a lot of practice and by looking at these equations specifically, group them together. So we'll talk about all lines, linear equations, as I said in the next chapter. So just by looking at that equation, you'll be able to tell I'm going to get a line, right? So by the way, 2 points would have been enough for us to draw the line. So lots of practice in looking at functions specifically, chapter by chapter, we'll be able to recognize what are we having. The reason why I'm talking about the graph of a function also is that just by looking at a graph, we can tell on whether or not we're dealing with a function or not. So we call this the vertical line test. So it says the graph of a function. So again, if you're dealing with a function, then any vertical or the graph of a function can be crossed by any vertical line in the most one point. That's a vertical line test. So the graph of a function can only be crossed by a vertical line in the most one point. So if a vertical line crosses the graph in more than one point, then that graph does not represent a function. Okay, so here it is. If you look at this and you're trying to run the vertical line test, you see that every vertical line crosses this graph in the most one point. And the same thing as I look at this function here. Okay, we already know it's a function. However, if you're looking at this circle and you think about some vertical lines that might cross it, as you see, here's a vertical line that crosses this graph in more than one point. Therefore, it is not a function. So again, just by looking at the graph, I can tell whether I'm dealing with a function or not. So here are a few graphs. Here we're telling you this is a function. Why? Because every vertical line seems to be crossing this graph in exactly one point. And of course, these arrows mean the graph is going to go on the same way over and over. By the way, this is some sine or cosine wave. Right here, I already know it's not a function. Here are some vertical lines. They're going to cross this graph in more than one point. And why does it fail to be a function? Because if you have 2 points on the same vertical line, that means what? These 2 points, by the way, they have the same x-coordinate when you look back to the x-axis. However, they each have a different y-coordinate when you look back to the y-axis. So this has some, let's say, y1 coordinate. This one has some, let's say, y2 coordinates. So there are different heights, but they have the same x in common. So remember what we said. To have a function, you cannot have the same x going to 2 different y values. That's not a function. And same thing here, as you see, this ellipse does not pass the vertical line test, so it's not a function. All right. So again, you may pause the video and decide for yourself if these graphs represent functions or not. And you will find out that, yes, the first one does pass the vertical line test. This one does pass the vertical line test, but the last one doesn't. Okay. Function notation is really helpful and important. So if an equation in 2 variables describes a function, that means that we can uniquely solve that equation for y. As I said, it really means that y comes to the power of 1. So we can get it to where we get y by itself and y equals something with x's. And so if we can say that y is a function of x, then we simply replace y with this notation. So this is function notation. And we read it as f of x. It's very unfortunate notation because just last week we discussed on how when you see a parenthesis, it means a multiplication. So it doesn't mean f times x, it simply means function notation, and we'll be able to tell from the problems we're solving that we're dealing with function notation and not some kind of multiplication. So if you see function notation f of x equals 5x plus 3, that means the same thing as y equals to 5x plus 3. So we simply replace the y with an f of x. We just simply say y is a function of x. And so we have this notation f of x. Now, when we use function notation, we can simply write things like, what is f of 1? F of 1 simply means, hey, x is 1. Can you replace it in the equation and tell me what y is? So it's the same thing as if x equals to 1, y equals to 8. That's what that says. So for example, what would be f of 3? F of 3 means to replace in that equation x with 3 and solve the problem. In other words, figure out what 5 times 3 is 15 plus 3 is 18. So again, that's the same thing as saying, and you don't have to rewrite it, but I'm just telling you, that's the same thing as saying if x is a 3, that gets paired up with a y of 18. So here's a function in function notation. Can you tell me what f of 0 is? Can you tell me what f of negative 2 is? Can you tell me what f of 3 is? And many times we actually are just simply renaming, for some reason, the variable. Again, I hope you have done this by yourself. Pause the video and see what you get. So when you change the label of the variable, every single time, all I'm doing in this equation, I'm replacing x with whatever's in here. And if in the parentheses x is replaced with a, well, that's exactly what I'm going to do. I'm going to replace x with a. And here again, here maybe one more. So obviously when we just relabel or rename the variable with another variable, then there's no way we can evaluate this expression because we were not given a value. We're just given another label. So again, be careful of the order of operations. Be careful with the signs. So that's going to be 28. It's 2 times 9 is 18. Minus 3 is a plus 3, and then plus 7. All right, so that's function notation. Again, remember, sometimes we are just given ordered pairs, and these ordered pairs can come to us as a table. So let's see how I might read this table of values. Here is, and it doesn't always have to be x and f of x. I am dealing with the name of the variable is n, and the name of the function is g, so g of n. The point is, if it says g of 3, that means n is 3. Yes? So again, it's just another name for x. Doesn't always have to be x. But the point is, if you substituted n with 3, what is the y value that you're going to get? Well, that's a 7. Okay. In this problem, we're going backwards. It says find n. So the g of n is 6. So g of n is 6. That means we're right here. And we want to know what n value goes with it. And so the n value that goes with a y, with a g of n of 6, is 4. So we can read, by the way, that means these are my x's and these are my y's, which can very well be renamed to other variables. So now let's do the same. Remember, a whole bunch of ordered pairs can be graphed on the xy plane, and we get the graph of it. So let's see if we can use the graph to find f of 2. So again, what does it mean, f of 2? That means x is 2. So let's look at the x-axis when we see 2. And then we want to find the y value to it, right? So what's the y value on this graph corresponding to an x of 2? So I'm going to go back, and here is where I'm hitting the graph when x is 2. When I look back to the y-axis, I see a 1. So in other words, that's the same thing as saying on the graph of my function, I have the point of coordinates 2, 1. And that's the only point that answers to an x of 2. Now, if it says solve f of x equals to 4, what does that mean? That means y is 4, and I want to find the x values, in other words, that get paired up with the y of 4. So here's my y, and here is 4. Now, if I look side to side, I'm actually going to find 2 points that are at that height of 4. So what x values answer to that? One of them is 3. And then I have a second point that's at the height of y. And then the other one is x equals to -1. So these are the 2 points I see on the graph that are at the height of 4. And that's still a function very well, because remember, for a function for the same x, you cannot have multiple y's. But no one said that for the same y, you cannot have multiple x's. You can definitely do so. Okay, so the point is, if I'm giving you an x value, there's only one y that answers to it. So here, one more. Here's a graph. You guys can try this. So again, pause the video maybe and figure it out by yourself, but I'm not going to pause. Here it is. If x is 0, what is the y to it? That's a 1. And if f of x is -3, what points do you have on the graph with a y of -3? Well, the x values to them are -2, I see, and +2. Okay. So here, last quick thing. Remember how I said for every x there has to be only one y value to be a function. Some functions are specifically one-to-one functions. So again, we talk about all the cars. Some of the cars are SUVs. Some of the SUVs are, I don't know, Honda SUVs or 8-seater SUVs. So specific type of function. So a one-to-one function is specifically a function. So we already established that we're dealing with functions in which every output value corresponds to exactly one input value. So also it means that for every y, there is only one x. So therefore 1 to 1. For every x, there's only one y, but also for every y, there's only one x. So you can't double up on anything. Every x, there's no doubling up on the x's. There's no two same y's. So yes, 1 to 1. Nope, not 1 to 1, because two different x's lead to the same y. So only one kind of x and one kind of y. Oh, I skipped over the middle one. All x's are different. All y's are different, so yes. All right. Now, 1 to 1 means that you also need to pass something called the horizontal line test. So also, no horizontal line can cross the graph in more than one point. So here you go, not 1 to 1. Yes, 1 to 1. It passes both the horizontal line test and the vertical line test. This one wasn't even a function. So we can't even talk about 1 to 1 functions if we don't even have a 1 to 1 function. If we don't even have a function. Okay. So here it is, 1.1.